Imagine you buy the fastest AI chatbot, generate stunning images in seconds, or watch a self-driving car navigate city streets. You probably think the magic comes from artificial intelligence itself, but behind almost every major AI breakthrough is a company most people never see. It doesn't own the biggest social media platform. It doesn't make the most popular smartphones. It doesn't sell AI subscriptions directly to millions of consumers. Instead, it sells the machines that make modern AI possible. That company is Nvidia. At first glance, Nvidia looks like a chip manufacturer, just another technology company building computer hardware. But that's not what its economics reveal, because Nvidia isn't simply selling computer chips. It's selling the computing power that fuels the AI economy. Every time a company trains a powerful AI model, builds an AI-powered search engine, develops autonomous vehicles, or creates advanced robotics, there's a good chance Nvidia is somewhere in the background. And that changes everything. Nvidia doesn't just sell chips, it sells the infrastructure every major AI company depends on. Everything else starts to make sense once you see that. When people hear Nvidia, they usually imagine graphics cards for gamers. That was true years ago. Today, Nvidia operates several interconnected businesses. The first is gaming, where GPUs power high-end PCs and laptops. The second is data centers, providing AI accelerators and networking equipment for cloud providers, research labs, and enterprises. The third is professional visualization, supporting industries like architecture, engineering, design, and visual effects. The fourth is automotive, where Nvidia develops hardware and software platforms for driver assistance and autonomous vehicles. Finally, there's software and AI platforms, the ecosystem of developer tools, AI frameworks, networking software, and services that make Nvidia's hardware far more valuable. Most people still think Nvidia's biggest customers are gamers. In reality, the explosive growth has come from businesses racing to build AI, and that's where the economics become fascinating. Suppose you decide to build a powerful AI model. You don't simply buy a graphics card, you're buying access to an entire computing ecosystem. You need specialized AI processors capable of handling trillions of calculations. You need high-speed networking, so thousands of processors can communicate efficiently. You need software libraries optimized for machine learning. You need developer tools that reduce months of engineering work. You need reliability, compatibility, and continuous updates. In other words, you're not buying silicon, you're buying time, you're buying performance, you're buying the ability to train models that would otherwise take dramatically longer, or be impractical to build at all. Think about it this way. A coffee shop doesn't buy coffee beans because it loves beans. It buys them because they're the essential input for every cup it sells. In the same way, AI companies don't buy Nvidia hardware because they love GPUs. They buy it because those systems are one of the core inputs for creating competitive AI products. The chips are only the beginning. The ecosystem is the product, and that's a hidden machine behind Nvidia's success. Now imagine you're the CEO of a company building the next generation of AI. You don't need one graphics card. You need thousands, sometimes tens of thousands, and suddenly, every decision becomes $1 billion investment. An advanced AI accelerator can cost tens of thousands of dollars before it's installed in a server, but the chip itself is only one piece of the puzzle. You also need servers, high bandwidth memory, networking equipment, storage systems, power infrastructure, cooling systems, and data center space. Then come the ongoing costs: electricity, maintenance, software, engineers, and security. A single large AI cluster can require investments measured in hundreds of millions or even billions of dollars. That is why only the biggest technology companies, cloud providers, research organizations, and well-funded startups can compete at the highest level. The barrier isn't just intelligence, it's capital, everything. So where does an Nvidia chip actually come from? It begins with years of research and engineering. Teams of designers create chip architectures capable of handling massive parallel workloads. Once the design is complete, Nvidia generally relies on specialized manufacturing partners to fabricate the chips using some of the world's most advanced semiconductor processes. Those chips are then combined with advanced memory, assembled into accelerator boards and server systems, tested, integrated with networking hardware, and shipped to customers around the world. But the journey doesn't end there. Cloud providers install these systems in massive data centers. AI companies rent or buy that computing power. Developers build models on top of it. Businesses integrate those models into products. Consumers interact with AI applications every day. Follow the money carefully. Raw materials become semiconductor components. Components become AI hardware. AI hardware becomes cloud infrastructure. Cloud infrastructure becomes AI services. AI services become subscriptions, enterprise software, productivity tools, search engines, healthcare solutions, robotics, and countless other businesses. Every step adds value, and at nearly every major step, Nvidia participates in that value chain. Most people think Nvidia's product is a GPU. That's only partly true. The real product is an ecosystem. Imagine buying a smartphone with no operating system, no app store, no developer tools, and no software support. The hardware would be impressive, but it wouldn't be nearly as useful. Nvidia approaches AI in a similar way. Its hardware works together with software platforms, developer libraries, networking technologies, and years of engineering knowledge. That combination makes it easier for organizations to build, train, and deploy AI systems. The result? Customers who invest heavily in that ecosystem often continue expanding it rather than replacing it overnight. That doesn't mean customers can never switch, but doing so can require significant engineering effort, testing, and operational changes, and that's one of Nvidia's biggest economic advantages. It's not simply selling faster chips, it's helping customers build entire AI infrastructure around its technology. That's a much stronger position than selling a single piece of hardware. The chip starts the relationship, the ecosystem extends it. From the outside, Nvidia looks unstoppable, but no company is without risk. The first challenge is competition. Major technology companies and chip designers continue investing heavily in AI hardware, each hoping to build faster, more efficient alternatives. The second is customer concentration. Some of Nvidia's largest customers are also developing their own custom AI chips. Even if they continue buying Nvidia products, reducing dependence is a long-term goal for many of them. Then there's geopolitics. Advanced semiconductor technology sits at the center of global economic competition. Export controls, trade restrictions, and supply chain disruptions can affect where advanced AI chips can be sold and manufactured. There's also the enormous cost of innovation. Every new generation of AI hardware requires billions of dollars in research, engineering, software development, and ecosystem support. In technology, standing still means falling behind. That is the price of leadership. So what separates Nvidia from companies that simply make computer chips? It's not just speed, it's not just engineering, it's the ecosystem. Think of it as the AI flywheel. More developers build using Nvidia's tools. That attracts more businesses buy Nvidia hardware. Higher revenue funds more research and software development. Better products attract even more developers. The cycle repeats, the chip is only one part of the machine. The ecosystem keeps the machine spinning. Imagine an AI startup receives $100 million in funding. Its goal is to build a powerful new AI model. A large share of that budget goes toward computing infrastructure. Some is spent on AI accelerator hardware, some on servers, networking equipment, storage, cooling systems, and data center capacity. Another portion pays cloud providers for computing resources. The rest funds engineers, researchers, software, operations, and ongoing development. Months later, the startup launches a successful AI product. Customers begin paying monthly subscriptions. Businesses license enterprise access. Revenue flows back into expanding infrastructure. To serve more users, the company purchases even more AI computing capacity. And once again, part of that spending flows back through Nvidia's ecosystem. The cycle repeats. That's why AI demand and Nvidia's business have become so closely connected. As long as organizations continue building larger, more capable AI systems, the demand for advanced computing infrastructure remains a critical part of the equation. When you hear the words artificial intelligence, your mind probably jumps to chatbots, robots, or futuristic software. But behind every breakthrough is an invisible foundation of computing power. Most people think Nvidia became valuable because it makes powerful chips. Now, you know something different. Nvidia didn't just build better chips, it built one of the world's most important foundations for the AI economy. The next time you watch an AI generate an image, write an email, translate a language, or help discover a new medicine, remember what you're really looking at. You're not just seeing artificial intelligence, you're seeing the infrastructure that makes artificial intelligence possible.